Hello everyone and welcome to my session. I'm Somaning Turwale and today we are going to talk about maximizing business continuity with Azure Site Recovery. Little bit about me. I spent 2 decades in IT and I'm currently a senior technical support escalation engineer at Microsoft, specializing in Azure backup and recovery services. My job is helping organizations to build a stable business continuity and disaster recovery solutions. So let's get started. Before we get into Azure Site Recovery, let's take a moment and talk about why business continuity is important. When a disaster strikes, whether it's a hardware failure, a cyber attack, or even a natural disaster, organizations need a plan to minimize downtime and data loss. Without a solid business continuity strategy, recovering from disruption can be slow, expensive, and chaotic. That said, implementing business continuity is not an easy and has many challenges. The organizations needs to consider cost, complexity, and compliance. What are the costs? Running a secondary data center, maintaining hardware, and managing infrastructure expenses can be expensive. And what is the complexity? Restoring from tapes, managing multiple data centers, and ensuring software compatibility can add operational overhead. And compliance, many organizations must meet regulatory requirements, retain data for specific periods, and ensure service availability, all of which can be challenging to manage effectively. We just talked about the challenges to implement the business continuity. Now we'll take a look at how Microsoft can help to overcome these challenges. This is where Microsoft and more specifically the Azure comes in. Azure helps organizations to tackle the challenges in a several ways. Reducing cost. With Azure, you don't have to pay for additional infrastructure or for power, cooling, or IT staff to manage a secondary site. You can only pay what you use. And with simplified disaster recovery, Azure Site Recovery automates failover and recovery processes. So instead of manual and a stressful recovery process, you can restore workloads with a just few clicks. Ensuring the compliance. Azure removes geographical constraints, allowing businesses to meet regulatory and compliance requirements more easily by replicating workloads across multiple regions. And now, scaling. ASR supports replication across both on premises and cloud environments, whether you are running Hyper V, VMware, or physical servers. What is Azure Site Recovery? It's a truly a safeguard your business. You need a robust BCDR strategy, one that only protects your data but also keeps your applications and workload operational, whether the disruption is planned or unexpected. That's where Azure Site Recovery comes in. ASR is a key part of Microsoft disaster recovery offering. ES replicates the workloads from your primary site to secondary location, whether on premises or in Azure. If a primary region goes down, workloads can quickly fail over to the secondary site, keeping your applications available. Once your primary site is restored, you can seamlessly fail workloads back to resume normal operation. ESR minimizes downtime and data loss, making your business more resilient to our disruptions. We looked at Azure Site Recovery. Now, let's consider why Azure Site Recovery. With ASR, you get a single unified solutions for disaster recovery. Azure Site Recovery supports heterogeneous environments like Hyper-V, VMware, and even physical servers. It also provides certified support for enterprise applications like SharePoint, SQL Server, Exchange, and Dynamics. You can also do the disaster drills with zero impact on a production environments. It also provides industry leading RTO and RPO, meaning your business experiences minimal disruption in the event of a failure. Key concept in disaster recovery. When we talk about disaster recovery, two key metrics help to define how prepared an organization is. The first one is recovery point objective. This tells us how much data loss is acceptable in the event of failure. Essentially, it's the maximum age of a data that can be restored. A lower RPO means more frequent backups or continuous replications to minimize data loss. Recovery time objective is the second one. This measures how quickly systems and services need to be restored after a disruption. It's a maximum downtime a business can tolerate before operation must be back online. One of the biggest advantage of Azure Site Recovery is that significantly reduces both RTO and RPO compared to traditional disaster recovery solution. With ASR, organization can restore the business and critical workloads in little as 15 minutes, minimizing operational impact and allowing for a faster return to normal. And also, ESR continuously replicates data, ensuring that failure happens quickly and with minimal data loss. Unlike traditional disaster recovery methods that rely on scheduled backups, ESR provides near real time protection, helping businesses maintain continuity even in the face of unaffected disruption. Why this matters? By becoming a low recovery time objective, near real time replication, and automated failure, Azure Site Recovery ensures that businesses stay up and running with minimal downtime without complexity and high cost of maintaining a secondary data center. With ASR, organization can recover faster, lose less data, and stay compliant, all while leveraging the power of cloud for scalable, cost effective disaster recovery. Now, as we know, Azure Site Recovery supports Azure workloads, Hyper-V, VMware, and physical. We are going to deep dive into the architecture of each one. Let's get started with Azure to Azure Site Recovery architecture. Now let's talk about how ASR works in Azure to Azure scenario and what components are required to set it up. When running the workloads in Azure, it's essential to have a disaster recovery plan in place to protect against unexpected outages, regional failures, or a planned maintenance. Azure Site Recovery enables seamless replication of a virtual machines from one region to another, ensuring business continuity with minimal downtime. How it works? ESR continually continuously replicates VMs from primary region to a secondary region. If there is an outage, your workloads are already synchronized and ready to run in another region. In the event of failure, planned maintenance, or a disaster, you can fail over to a secondary region with a minimal disruptions. ESR automates this process, ensuring quick and a smooth transition. Once a primary region is restored, you can fail back to your original environment seamlessly ensuring normal business operation with minimal data loss. Now let's look what all the components are required to set up the Azure to Azure scenario. To set up Azure to Azure disaster recovery, you need the following key components. The VMs running in primary region that needs to be replicated to your disaster recovery target region. Now, we need the recovery vault, the recovery vault where Azure Site Recovery stores metadata, configuration details of for a replication, failover, and failback. And now we need a replication policy. This defines how often data is replicated and retention of recovery points. This helps ensure that you meet your recovery point objective, that means RPO. You need a target region, the secondary region where your VMs will be replicated. Microsoft provides paired regions to ensure optimal disaster recovery. And then you need network configuration, especially VNet, in the target region to connect the recovered VMs after a failover. You need a subnet that mirrors your primary region setup. If you have a public IP, then you need to you need a connectivity after a failover. So, replication policy and recovery plans. Replication settings to define a frequency and consistency of the replication, and recovery plans to automate the sequence of failure operation, including dip between the application. Say, for example, if you have a three-tiered application like tier 1, tier 2, and tier 3, whenever you are doing the failover from one region to another region, you need to ensure that first your Active Directory environment comes in, then your databases comes online, and then your web application comes online. To automate that process, you can use the recovery plans. Then you need a managed disk. ESR supports managed disk, eliminating the need to manage the storage accounts. For enhanced performance, ASR replicates data to a storage blob before writing into the managed disk in the target region. You also need Azure Automation account, which is optional. If needed, you can use the automation to run the runbooks to trigger custom script during failover or failback. Since we already covered Azure to Azure scenario, now let's shift our focus to how Azure Site Recovery helps to protect workloads running on Hyper-V by replicating them to Azure. Many organizations still rely on premises infrastructure, including Hyper-V virtual machines. While this setup provides a control and flexibility, it also presents challenges in terms of disaster recovery. If an on-premises data center experiences a failure, whether due to hardware issues, natural disasters, cyber attacks, organizations need a way to quickly recover their workloads in the cloud to minimize downtime. This is where ASR comes in. How it works? ASR continuously replicates Hyper-V virtual machines from on-premises environment to Azure. This ensures that up-to-date copies of your workloads are always available in the cloud. If a disruption in a primary environment allows ESR to fail over to Azure, instantly bringing your critical application back online. Once your environment is restored, you can fail back workloads from Azure to Hyper-V infrastructure, returning to a normal operation with minimal data loss. What components are required? To successfully configure Hyper-V to Azure, you will need the following components: the on-premises Hyper-V host, the Hyper-V servers hosting the virtual machines that need protections. ESR supports both standalone Hyper-V host, Hyper-V clusters managed by System Center Virtual Machine Manager. we call it yes. Then we need a recovery vault, as we talked in Azure to Azure scenario. Vault stores all the replication and recovery settings. These are the core component that manages failure, failback, and recovery plan. Then we need ASR provider and agent. If you are using SCVMM, you need to install the ASR provider on the VMM server. And if you are using the standalone Hyper-V host, then install the ASR provider and the agent on the Hyper-V host. The replication policy defines how frequently data is replicated and how many recovery points are retained. This determines your RPU. Then you need Azure target resources like managed disks, VNet, and recovery plans if you wanted to uh, automate some of these tasks. We have already covered Azure to Azure, Hyper-V to Azure. Now we are going to cover VMware to Azure or physical to Azure. We have two versions of VM Azure or physical to Azure. One is classic and one is modernized. Classic is going to be deprecated soon, so I'll not be talking that. So now we are going to talk about modernized approach to VMware or a physical to Azure Site Recovery. Let's talk about how ASR helps to protect VMware virtual machines and physical servers by replicating them to Azure. Many organizations still run critical workloads on VMware environments or on physical servers, whether it is in their data center or in a co-location facilities. While this setup offers control, it also introduces challenges: scalability, cost, maintenance, and most importantly, a disaster recovery. Traditional recovery methods like secondary data centers, tape backups, manual failover processes are often slow, expensive, and complex. This is where Azure Site Recovery modernizes the disaster recovery, providing cloud first, automated, and cost effective solution. How it works? ASR continuously replicates VMware virtual machines or a physical servers to Azure, ensuring near real time protection without impacting the performance. If an outage occurs, whether it's a hardware failure, cyber attack, or natural disaster, you can fail over workloads to Azure instantly, restoring services with minimal disruption. Once your on premises environment is back online, you can fail back workloads from Azure to your VMware environment. If it is a physical to Azure, then you'll not be able to fail back to physical servers. In that case, you need to live in Azure or you need to have an alternate failback with VMware option. Now, let's look at the key components involved in VMware to Azure or physical to Azure. To set up VMware or physical to Azure Site Recovery, you need the following key components. On-premises VMware or physical servers, these are the workloads that need the protections. Then we need, as usual, Azure Site Recovery Vault. That's the heart of ASR, managing replication, failover, failback, compliance settings. All metadata will be stored in Recovery Service Vault. Then in on-premises, we need a replication appliance which can be installed on Windows Server to handle data replication between VMware or a physical servers to Azure. And this appliance connects to a VMware vCenter or a standalone ESX host to replicate the VMs and manages replication of a physical servers to Azure. Then we need a mobility service or mobility agent which will be directly installed on a VMware machine or a physical server to enable real-time replication to Azure. In our target Azure resources, we need a VNet. Once you fail out the VM, we need a VNet to connect, and then we need a managed disk. ESR replicates workloads to these disks for efficient storage and faster recovery. Azure Virtual Machines, once failure happens, VMs are automatically provisioned based on the replicated data. Then we need replication policy and recovery plans, which replication policy defines the recovery point objective to ensure minimal data loss, and recovery plans, which helps you to orchestrate the failure with recovery plans, brings services online in the right sequence. Now we'll take a look at key success factors pre-implementation. Successfully implementing Azure Site Recovery requires careful planning, training, and continuous testing. A well prepared approach ensures seamless disaster recovery and minimizes operational disruptions. Comprehensive planning. Before deploying ASR, it's crucial to conduct thorough testing, a thorough assessment of your infrastructure to ensure a smooth transition. Key considerations includes infrastructure readiness, analyze on-premises and cloud workloads to determine replication needs, network capacity, evaluate bandwidth requirements to prevent latency issues, compliance and security. Map out industry regulations to ensure your disaster recovery setup meets the governance requirements. Implementation and roadmap. Define a structured rollout plan tailored to your organization need. Through training, ensure IT teams are equipped with right skills and certifications in Azure, disaster recovery, best practices, and ASR management. Cloud hands on training to familiarize teams with failure and failback procedures, troubleshooting, and automation workflows. Provide ongoing learning opportunities such as Microsoft Learning Modules and real world lab environments. Regular testing. Schedule a monthly failure drills to validate workloads are resilient. Conduct quarterly full scale recovery simulations to assess overall disaster recovery readiness. Monitor system performance continuously to maintain 99.9 recovery reliability and proactively resolve potential issues. Now let's look at a step-by-step guide to implementing Azure Site Recovery. In the assessment phase, if you are using VMware to Azure or Hyper-V to Azure, Microsoft provides a deployment tool. You can use it. We call as a deployment planner. You can run that tool for a week on your environment to understand your workload, dependencies, network performance, business continuity requirements, and recovery time objective and recovery point objective to align with the business needs. Identify applications requiring high priority protections. What planning you need to do? Design the replication architecture between on-premises or Azure to Azure environments. Map application dependencies to prevent failure during recovery. Develop runbooks to automate recovery sequences and minimize manual intervention. How you can do the deployment? Set up a recovery vault and configure replication policies. Enable source to target VM replication with continuous monitoring and automate failover and failback processes for seamless recovery. Testing and optimization. Conduct bi-monthly failover drills to measure recovery speed and validate failover configurations. Analyze performance metrics to refine disaster recovery procedures. Update recovery plans regularly based on insights from a real-world testing. Conclusion: strengthen the business continuity with Azure Site Recovery. At the end of the day, business continuity is all about resilience. Being able to recover quickly, minimize disruptions, and keep operations running smoothly no matter what happens. Azure Site Recovery makes it possible by providing fast, cost effective, and highly reliable disaster recovery solution. With recovery times up to 90% faster and cost savings between 40 to 60%, ESR eliminates the need of expensive secondary infrastructure while ensuring 99.9 recovery success rates. Beyond just efficiency and cost savings, security and compliance are built in, giving organizations a peace of mind. Their critical workloads are protected, whether they are in the cloud or on premises. Now it's the time to modernize your disaster recovery strategy by leveraging ESR's automation, scalability, and enterprise grade capabilities. You can future proof your business and ensure recovery and without any disruptions. A big thank you. I appreciate your time today. Thank you for joining me. If you have any questions, feel free to reach out to me.